Hello guys, my name is Prachi Thakre and today we will going to cover binary search. So first of all, what is a binary search? So binary search algorithm is one of the widely used searching algorithm or techniques. It can be used to sort arrays. So in this searching techniques, we follows the divide and conquer strategy. So in this searching, space always reduced to half in every iteration. So in a binary search algorithm, it is a very efficient technique for searching, but it needs some ordered way, some arranged way of array on which the partition of array will occur. So let's see some example of this. So in a binary search, given a sorted array of integer of the element, there are be either a increasing order or maybe a decreasing order. So like in this array, elements are arranged in a increasing order. So now we are going to check 78 is exist or not in the array. So does 78 exist in the array? Yes, 78 exists in this array. So in which position? If we are starting the numbering or indexing from 0, so 0, 1, 2, 3, 4 and 5th. Okay, so 5th position 78 will be exist. So now we are going to implement the logic behind this all this searching approach. So first we divide the array in a two parts and select a mid element. So the mid element will be 43. So now we are comparing this mid element with the searching element. There will be a three cases. Three cases will be like first searching algorithm is equals to mid element, or maybe searching algorithm is greater than to the mid element, or searching algorithm is less than to the mid element. So clearly we can see that 78 is greater than to the 43. So we are looking for 78 in a right half of the array. So next we are finding some new mid. So now new mid equals to 66. Again we check. So again 78 is greater than to 66. So now we are going to check in a right half of the array, and now the new mid will be equals to 78. Again we match or comparing this mid element to the searching element. So now 78 equals to 78. It means the searching element are present in a last element of the array. So this technique is called a binary search. Now we are going to implementing how to implement all this logic. So there will be a two way to implement this logic. First, iterative approach, and second one is recursive approach. So in a iterative approach, we are using loop control techniques. Okay, so just see that this is a function binary search array and size of the array, and this loop will be run until the begin is not equals to end. It means the starting to end of the array, this loop will work. So mid index is equals to begin index plus end index divided by 2, and if item it means the searching element. There will be a three cases. It will be a equals to mid element, greater than equals to mid element, or less than to mid element. So if item or searching element is equals to mid element, then return mid element. If not, then we are searching in a right half of the array. If not, then we are going to search in a left half of the element. So this is all the iterative approach. Now jump to the recursive approach. So in a recursive approach, the recursion will be simply a function called by function called itself. Like we are seeing that binary search is a function array item searching item begin and end of the end item. So this will the condition will be if begin is less than equals to end. So we find the mid element, then comparing mid element with the searching element. If mid element equals to atom, then return mid element. If not, then if searching element is less than to the mid element, then we are going to search in the right half of the array, and if not, then we are searching in a left half of the array, mid index minus 1, mid left half of the array. If we are not finding the element in all of this array element, then we are simply return -1. It means element is not found. So this is a recursive approach. Now we are going to talk about time complexity. How much time taken by us to implementing this approach or this logic. So simply in a each iteration the searching space is getting divided by 2 and divided by 2. So array are divided in a two parts. That means the current iteration have to deal with the half of the previous iteration, a previous array or sub array. So the step is continue until the begin is less than 2, and so best case would be a first element is matched with the searching element. This is very simple. I mean, best case or best time complexity of this algorithm is big of 1. It means the first value will be a match with the searching element, and worst case or what time complexity will be the last element will match with the searching element. It means that in this case the time complexity will be big O of log n, and average time complexity will also big O of log n. So let's calculate this time complexity. So let's k is the number of iteration. So we are seeing the 4 iteration, like the process will be terminated in a 4 iteration. We assume that. So in a searching algorithm we are taking that the every iteration is divided by 2 and a half of the every iteration. That means the length of the first iteration will be n by 2. The length of the array of the next iteration will be n by 2 divided by 2. It means that in a third iteration the array of length would be n divided by 2 and divided by 2. So this means in a kth iteration the element the array length will be n divided by 2, 2 to the power k. Similarly, in a fourth or fifth iteration the length will be n divided by 2, 2 to the power 3, and so on. This is the length of the array. This will be half in every iteration, and simply we are just take the k division. So length of the array becomes 1. Therefore the n divided by 2 to the power k, length of the array equals to 1. So n is equals to 2k, applying the log in both sides. So simply log n is equals to log 2 to the power k, and there will be a log base 2. Okay, so log n is equals to k log 2, and we know that the log a is equals to 1 if base 2, if log base 2. So therefore the k is equals to log n. There will be log base 2 n. So this is the time complexity of a binary search algorithm, log base 2 n. And now talk about the space complexity. So no auxiliary space is required for simply binary search implementation. The binary search algorithm space depend on the two techniques, and there will be a two ways to implementing the algorithm. So this is all depend upon the ways which we have choose for applying this algorithm. So first one is iterative method, or second one is recursive method. So in a iterative the control through the loop control. That means the uh, if you are searching the first element would be a uh, searching element. That means the time complexity or space complexity in this case or in this iterative method should be big O of 1. In a recursive method no loop, there will be a recursively we are calling function again call by function. So this process will be some lengthy, and there will be a mix and mean value. Max and mean value are used to boundary conditions. So the space complexity on this binary search would be a big O of log n. So this is all about space complexity and time complexity of binary search algorithm. Thank you so much.